it hits me, oh my gosh, this is that triangle.
You know, there's explanations for everything that occurred in the Rendlesham-Mars incident that doesn't involve aliens at all.
It was completely silent. It comes right over our heads.
It's someone classic flying saucer really standing in a clearing.
He turned over to my father, held his hand, and he looked in his eyes.
Welcome to Podcast UFO for our live show. During the show, feel free to participate live in our chat room. And don't forget to like us on our very active Facebook page.
Hello and welcome to the show. I'm Martin Willis, your host, and welcome to the show. And we have a good one for you this evening. We have our guest, Marc D'Antonio. He's a repeat guest, and we're going to be talking anywhere from possible alien and alien detection, he doesn't know that yet, to space junk, which I really want to talk about. It's very interesting to me, to the new Mars InSight lander. Also, China has landed a high-definition lander on the moon and taken some interesting images. Also, I want to announce that after this show tonight at 8:30 p.m. ET, Marc will be doing some type of show he's going to talk to us about where anyone can join in. It's actually through his telescope and all that. So we're going to talk about that as well. He has a little observatory right on his property in Connecticut. And so that will be fun. And so just a couple of things. We are live. Anyone can watch the full shows on YouTube's. Is there more than one YouTube? No, just YouTube. Every Tuesday night at 6 to 8, and that's Eastern Standard Time. You can also check out our website, and on our website you can watch it there as well. And it's also on KGRA Radio at the same time. We have a chat room over there and a chat room on YouTube. You're welcome to join in. We have Amanda helping us out with the chat tonight. Going to be sending questions, forwarding questions to myself to ask Marc from both chat rooms, actually. So that should be interesting. We will take calls in the second hour of the show too, as well. And let's see. I want to thank everyone that helps out with the show. I really do appreciate it. Without your help, I couldn't do that. We also have a blog that Chris wrote in Tasmania. Send it in, and it's about Jeremy Corbell and his recent Lazar movie that's coming out. And today, I believe it's out today. Is today the 4th? Yes, it is. I do believe it's today that it has come out. So anyway, all that is on podcastufo.com. We also have an active Facebook page with over 20,000 people and news stories posted every day. Peggy helps out with that. I want to thank her for doing that. And all right, I guess we're ready to roll. Alejandro, thank you for joining us.
Hello, my friend.
Yeah, thank you for joining us as usual. And
it's my pleasure.
We missed you last week, so it's good to have you back.
Oh, was I not on?
Yeah, you were going to the airport. You forgot. You went to the airport.
Was it last week or the week before? Last week, I think, was when I was trying to do something, and it was the internet was crappy in my room.
Oh, that's
right. I apologize for that.
Yeah. We tried to do a pre-record, and that didn't work out. Yeah, that's right.
Sorry. I feel real bad about that.
I'm sure you did.
But I did. Okay. But at risk of upsetting, I mean, I got my whole background, and I made sure I've even got back here. I know I probably shouldn't move my camera, but I've got a whole little UFO high-tech setting back there. I could see Marc here on my end already, and he gave me the thumbs up there, so he enjoys it.
Yeah, you have quite a bit of paraphernalia, UFO paraphernalia.
I do.
Yeah, wow.
Just because we keep getting more and more stuff for this store, the UFO Congress store. We got all kinds of UFO junkies and alien junkies and stuff like that. And Marc spent some time here, your guest, actually, just a few weeks ago.
That's right, yeah.
He spent a few days hanging out here and checking out our collection. And we've gotten even more since he's been here. So he inspired us. His strange alien-like behavior really helped us think out of the box.
Now, those little UFO... That thing that's actually, you want to tip the camera? This,
of course, is
for this is for YouTube only, of course. But is that actually? It actually, it's not touching the ground, right? It's actually hovering.
See that?
It's electromagnetic.
Actually hovering.
And
it's alien anti-gravity technology,
course.
which Mark will tell you.
Yes, Stephen Greer has harnessed that somehow, right? Anyway, sorry I slipped that in there. Now, do you sell those actually on your website?
We do. So this is a black one. I think we're out of them. I think you know Dale. Remember Dale? He's an artist who.
Oh yeah.
He bought the last one of this color, but we have some more that are all gray and all silver. They're actually super, super cool.
Actually,
I don't even know which is my favorite because they're all equally cool.
Let's just quickly tell who Dale is. He's was it The Simpsons? Was that?
Yeah, he's a art character designer for The Simpsons. So in fact, he's done me, and we've got a whole set because, of course, at Open Minds, Jason McClellan used to work there, and Maureen Ellsbury. So he did us kind of doing a podcast radio show, which was kind of cool. And he's got one of Lee Spiegel and a few others that he's done.
Lee Spiegel's Triangle UFO.
Well, that's not he Simpsonized all of us, all of the people I was talking about. But yes, he did do that artwork of Lee Spiegel's amazing sighting.
Right.
And what's great about Lee Spiegel's sighting is that he went to this location at the behest of J. Allen Hynek, who, of course, is a real-life person who is going to be portrayed in this new History Channel television show called Project Blue Book here that starts in January.
Right. That will be fun. I can't wait for that to get going.
I got to see the last couple episodes. Did we already talk about that?
I think
on your show.
So possibly.
It's really good though. It's really cool. And have you ever had Bryce Zabel on your show?
Oh yeah. Yep.
Hollywood guy.
Yeah.
So Bryce Zabel did the show Dark Skies, and what was interesting is I was expecting that they were going to try to do an X-Files type of show with this Project Blue Book, but it's actually much more Dark Skies. It really felt like Dark Skies. I even emailed Bryce. I was like, hey, I just saw the first couple episodes of Project Blue Book. I'm not sure if you got to a premiere. He said, no. Why? Is it like Dark Skies? And I was like, yeah, exactly. It reminded me very much of your show. Just because it's historic, and if anybody remembers Dark Skies, it was more, accurate towards speculation about, government conspiracies and stuff. And of course, this is based on real Project Blue Book cases, but they add this conspiracy stuff. So they even add Men in Black and stuff like this, stuff that Hynek really didn't get involved with necessarily. But of course, they've got to add some drama to the show. And many speculate that I even had the guy on, you've had him too, I think, the guy who wrote the recent autobiography or a recent biography of J. Allen Hynek. And he says, nobody knows. There are hints that Hynek felt that they were hiding information from him, but nobody knows for sure how Hynek felt about that or if he knew more than he let on. But we all know from this memo when they did close Project Blue Book, the Bollinger memo, where this general essentially said, go ahead and close Blue Book because we send the most interesting cases elsewhere anyway.
I got to know Tom Snyder, talk show host. Are you familiar with who he is?
Really?
Yeah.
Yes, very much so. The white hair.
Yeah.
Tall guy.
Dan Aykroyd used to imitate him. Actually, he said he was actually friends with Dan Aykroyd. He thought that the imitation was a riot. But anyway, I'm still in touch with Pam Burke. That's his wife, a widow. And I saw something about Tom Snyder interviewing J. Allen Hynek. So I said, hey, Pam, what did you think of J. Allen Hynek? And she said, oh, my God, that was one of my very, very favorite and Tom's favorite guests. She said he had such a sense of humor. It was really great to talk to her about it. And
that's fascinating. I don't know if I told you this because I guess I haven't been on because I was at AlienCon also a few weeks ago and in Baltimore, and I was doing several different talks, and one of them was about Spielberg. In the beginning of the show, I talk about Close Encounters, which was inspired by Hynek, so I go over Hynek a bunch, and I talk about how great Hynek is. I even mentioned how excited I am about this new History Channel show. Well, at the end of my talk, this guy walks up to me and says, I'm Paul Hynek. This is Hynek's son. Yeah. And I said, thank you for all the nice things you said about my father. So that was really cool. But I did include a video of Hynek where he makes a joke about flying saucers. And remember, if you are offended by this joke at all, it's Hynek who said it, not me first. But he said, if you want to see a flying saucer, one of the jokes is and he was complaining about the term flying saucer. But he said, one of the jokes out there is, if you want to see a flying saucer, just goose the waitress.
Oh, jeez. I'm glad you didn't say that. Yeah.
Yeah. I'd never say something
He never
like
knew
that.
of the Me Too movement. You know what I mean?
Right.
Yeah.
Yep. That was prior to that. That was the
Yeah.
men behaving badly or whatever kind of era.
Yeah, for like millennia.
Yeah.
Yeah. All right. Well, you got anything going on in the UFO world this week?
Yeah, I mean, you mentioned it. The Lazar movie launched today. I'm looking at my email, and let's see, because I did already see it. I got a preview copy to look at, and I can answer any questions about it if you want. But it did launch today, too, because I did pay for it, because there's extras, and I want to help support Jeremy because he's a buddy. And I got my email at 1 a.m. I pre-ordered it to download it. So, yeah, it is out there today if you want to check it out. Lots of people excited. If you go to Jeremy's Instagram, which is great because you can see all of the excitement, the big line of people outside of the theater. So very exciting. I'm bummed I couldn't be there, but Dale, the friend we just talked about, was there. I know that Jason McClellan was there, and Ryan Sprague.
Wow.
And David Navarro, the rock guy, the rocker, he was there. He was Instagramming about it last night. It looked like he got to actually talk with Bob Lazar, who was there. I didn't even realize Bob Lazar was going to be there. So, yeah, pretty interesting stuff. Now, I am curious if it's okay to talk about that right now, about what this blog post is, kind of the gist of the blog post. And also, if you don't mind, I kind of would like to bring Marc on. And Marc, he's listening. I can see him, his camera there waiting on the ISS, or it looks like he's in a submarine or something. But I sent a link in the chat. If you could look at that, because there is a UFO video that's kind of making the rounds right now. And
in the chat,
I'd like to kind of discuss that next.
Yeah.
Our Skype chat.
Oh, I don't know if I can get to that right now with the way things are.
Hopefully Marc can, because I'd like Marc to look at it. Yeah, and then we'll talk about it.
Marc, let me introduce Marc. Repeat guest, Marc D'Antonio. We're going to pull him up on the screen, a little blurry, but that's all right.
I want to hear about this blog post on Lazar. Or did you read it yet?
Did I read my own blog post?
Oh, you posted it.
Yeah, it's on my website on Podcast UFO. It's from a gentleman, Chris. He's been writing guest blogs from Tasmania, and basically,
did you read it?
I read through it late last night.
Good.
I can't remember the gist of it though. Is that he thinks there's definitely a lot to the Bob Lazar story, and I actually have gotten a few emails today of people saying, what do you have against Bob Lazar? I don't have anything against Bob Lazar. I just question certain things like his education, his claimed education. And when someone claims one thing and it turns out to be wrong, then I kind of question. It's kind of like the appraiser in me, the antiques appraiser. I question everything if one part of something's wrong. So that's basically it.
Mm-hmm. No, that makes sense. And people will ask, and has been these comments, what does Stanton have against Bob Lazar or some? People are looking at it wrong. You don't have to. This is about, getting to the truth and to the facts. And just because someone seems nice, like there are some researchers, well, I met this person, that's why I can say they're telling the truth. Well, just because you've met them, and even just because you like them, doesn't mean that what they're saying is completely accurate. So it's incumbent upon people like us who are out there trying to share information to heavily scrutinize, what people are saying. And especially someone like Stanton, when they hear, information that they follow up on, like the education or the science, then they have to say, hey, this science is wrong. I know this to be wrong. Even if they're like, I'm sorry, but, you still got to convince me that this science is correct. So, I think it's fair that we be critical of people I always go back to Sagan. Extraordinary claims require extraordinary evidence, and so we need to seek that.
Actually, it wasn't Sagan that coined that phrase, but I get what you're saying.
Yeah, it is, isn't it?
No, it was someone before him.
Oh, really?
Yeah, he stole it from someone else and took all the credit.
Oh my gosh!
Yeah.
Killjoy.
You can go ahead and Google that if you don't believe me, listeners.
Oh, I believe you.
Before I
I'm
get
just
the
curious.
hate mail. Hey, I want to introduce Marc D'Antonio because
Okay.
I started to and I forgot why
sorry.
I changed.
It was my fault. I distracted you
that's
and
okay.
brought you to Lazar.
He needs almost no introduction at all. He's an astronomer, and he does a great show. He's also on KGRA radio and does a Skywatch thing I joined the other night. Actually, not a Skywatch. It was actually talking about the moon. We can talk about that. Marc D'Antonio, welcome back.
Hey, thank you so much for having me. Hi, Alejandro. How you doing, buddy?
Hey, buddy.
We had a good time when I was out there. I was doing a talk for the Phoenix MUFON, and then I had to teach a week later in the desert for the boot camp for the Mutual UFO Network. And Alejandro said, hey, come spend a few days with us. So I did, and it was a wonderful time. And I got to play with those little UFOs that were hovering. And I got to tell you, I had a lot of fun with that. A lot of fun with that thing.
Mark and I were like kids playing with all of our toys. We did a bunch of astrophotography, which was a lot of fun. And we made a video about, misidentifying, certain things like bugs as UFOs or birds. And then Mark played a little bit of didgeridoo. So if you want to see him doing some didgeridoo, you can go to the Open Minds YouTube and see that. But it was really fun. I felt like a little kid, like, when you were little and you got to go home, your mom comes and picks you up, and you're like, I don't want to go. It was kind of sad seeing Mark leave. We had a lot of fun.
I felt actually because, he basically lives in a giant toy box. And it's
you do too. Look at your place.
My place notwithstanding. Okay.
Yeah, Mark, you're forgetting I've been there, so I can vouch for that.
Yeah, you have.
Yeah.
You have.
Yeah. Now, and you do the FX models for also. Do you want to talk? Why don't you just say quickly to the listener who's not heard you before what that's all about?
Yeah, I mean, FX Models, letter F, letter X Models is a visual effects company that I started back in 1995, believe it or not. And I started it as a way to start making these very elaborate, very detailed models for movies and commercials and so forth. Well, it turned out that I worked an awful lot for the Navy, and I spent a lot of time working for the Navy, many years actually, doing these projects. And the benefit of FX Models was that I learned a whole host of new techniques, especially when I was working alone a lot of the time. I had to be smart about it. I had to learn how to work alone. And that was much better for me because I ended up creating and getting machinery to help me do all this. That led to getting into astronomy more because I got my degree in astronomy, as you know, and I've been an astronomer for science centers and so forth. And so what I did was I ended up putting an observatory on the front lawn. So it looks like a big white minion out there, okay, with a round head. It's like Stewart, But tonight is a special streaming night, for Sky Tour live stream. It's called, and that's on YouTube. And it's a companion stream to Sky Tour Radio, which, as you mentioned, is the KGRA radio show that we do Sunday nights at 9 p.m. Eastern. And so Sky Tour live stream tonight is special because we're actually doing something a little different. We're actually using the observatory completely remotely because this observatory is being prepared to get shipped to Arizona. And
I remember you talking about that.
Yeah, and it's still something that we're planning on doing. And so to that end, I have to really make this thing robust and standalone so that no matter what, I can operate it and run anything that goes wrong through the internet. So that's what I'm doing today. And tonight's stream is going to be the first time we debut this new process and procedure. So tune in if you want to see things either go horribly wrong and laugh your butts off or watch things go wonderfully right.
Yeah. Now, how can they find it, Mark?
It's a Sky Tour live stream. That's Sky Tour, all one word, live stream, all one word. And it's on YouTube.
And it's probably showing there now, like if someone wanted to save it. And is that a regular, that's a regular show that you do, right?
Well, it's a clear night stream.
I see.
That I do, and Amanda Curran, who is my co-host on SkyTour Radio, is also my co-host on SkyTour Livestream. So it's all things SkyTour, everything's SkyTour for us. So we actually do. She creates SkyTour news. She has SkyTour stories and a whole bunch of other things that she does that are really cool in the SkyTour arena. And then I do the live stream, and I'm part of a bigger picture, which is called astroimaginglive.com. That's the website. And there we have Bill New York Skywatcher, who's actually one of KGRA's producers. And we have P&K, Paul and Keith, P&K Space Imaging. Those guys look at the moon and the planets. Bill New York Skywatcher looks at meteors and big meteor showers. And then I'm the one that looks at the deep sky objects. So we go to particular objects in the sky. We look at comets. We look at asteroids. We look at deep space nebula, all these things. And we take people on a tour, and I don't just show them. I mean, I'm an astronomer, so I tell people about them, and I give them a little idea of what they're looking at. Now, when Alejandro and I went out, basically that devolved into playing with lasers on the mountain in the distance, and we were just drawing our names in the mountain with lasers and stuff, and that was really cool.
Karen did a perfect star. It was amazing.
Wow.
Yeah, I couldn't believe it. I laughed because I didn't think she'd possibly do it, and then she turns around and she does a perfect star the first time. I was like, wow, okay.
You're going to have to share that picture. It's a good one.
Hey,
it is a good one.
We have about 4 minutes to the break coming up. So, Alejandro, what is it exactly did you want to ask Mark?
Yeah, sorry, I'll leave it to break. And I just wanted to say one of the news stories out there is a UFO at the Outer Banks. Yeah, I figured you did, and you can correct me if I'm wrong. It is a spectacular looking video because you see 2 or 3 lights out over the ocean that are very bright. But to me, I believe them to be flares. Some people disagree, and Mark can speak more to this. People say, well, flares, you can see smoke, you can see them descending, they flicker, and none of those things are necessarily true. I see flares often. They can be very bright, these new military flares. They're falling at such a slow speed that they don't look like they're falling at all, and I've got video on Open Mind showing this.
Yeah, they're on a parachute. You're right.
Yeah, so they are flares and you don't see the smoke on these flares either. So that's what do you think, Mark? What do you think they are?
I actually photographed exactly this type of thing when I was in Arizona because when I was out in the desert, I had my own private Phoenix lights, basically. Luke Air Force Base was doing maneuvers, and they were dropping parachute flares. And when they did, and those flares had to be 70 miles away from me at least. And when you look at these 2 bright lights, these 2 bright lights that were on the horizon, they looked eerie. They looked unearthly. But the thing is, they're not unearthly. And when you zoom in on with the camera and get up close, you can see the smoke. The smoke is not visible to your eye because it's such a low surface brightness to the smoke. But it's there. And then, of course, these flares are descending, actually at a rather at a parachute type rate. They're really not. And I think you're absolutely correct. I'm with you on this. I think these are actually parachute flares.
Sorry, guys. I know some people are going to get upset, but...
Well, they can be upset with me then because,
Yeah,
I agree, that these are probably... Well, I'd have to say 99.9% that I believe these are parachute flares because they never change orientation relative to each other. They're descending at a rate that's concurrent and, well, that's actually, coincidentally... like the same for a parachute flare drop. So I don't see any reason why these aren't parachute flares. And the color
I agree.
is the important thing.
Well,
the camera's not picking it up as well, but it's an unearthly shade of orange that these things look, and I'm sure it was startling.
We have just like a minute or so to break. So I just want to say the Phoenix lights, a lot of or I think maybe perhaps all the video that you see, we have 1 minute left till break, that you see is flares. There may be one that is not possibly...
There's only one I'm aware of that might not be flares, but the rest, yes, you're right, are the flares. Because at 10 o'clock there were flares. Now, I'm not sure, though, because from 8 o'clock earlier in the day, there were sightings out around the Phoenix area and all the way up to, like, Kingman and Needles, just over the border in California. I don't think those were flares, but certainly the 10 p.m. were flares over Goldwater, and I think Mark will concur with that.
And that really kind of that was, if they were going to cover up, they did a really good job because
It's not apparent whether they were trying to do that. We don't have any evidence that they were definitely trying to, but you're exactly right. If they were doing that, it was a genius way to distract people.
Absolutely. Okay, it's time to go to break. So, all right, thank you so much, Alejandro. I appreciate it.
Have a great show.
Thank you. And all right, everyone, we'll be back with Marc D'Antonio in just a second. And I'm live on KGRA Radio, YouTube, and Podcast UFO. This is Martin Willis. Stay tuned. We'll be right back after these messages.
After these messages, we'll be right back.
Oh, yeah.
You're clear.
All right. What do we have, like 4 minutes?
4.5 minutes.
Okay, sounds good. All right. So, Alejandro, you're still on.
Yeah.
You can stay on. Yeah.
Okay, for the break here?
Yeah, why not?
Because we're doing, this is on YouTube still, right? The break?
That's right. And usually in the break we take either questions or we talk about something that we weren't talking about, so it doesn't mess up when we get back on KGRA Radio. But
well, I don't know if you were going to ask Marc this, but I want to hear what Marc thinks of Lazar. And for both of you, I would like to have this discussion again after you see Jeremy's film, because there is some new stuff here, and Lazar speaks for himself and some of the things that I think all three of us are critical of. But what do you think, Marc?
Actually, I listened to George Norrie interview Bob Lazar the other night. It was an older show, probably, but it was Jeremy Corbell was there with Bob Lazar, and they were.
It was new, actually.
Yeah, but when I say older show, I mean it was like last week or 2 weeks ago, or whatever it was. So, but yeah, and listening to that, I started listening to the show kind of with that skeptical approach, thinking, I've heard all the things about him and all these things, but then. Listening to him respond, I actually got the impression that he might actually there might be something to him, more than I
think he believes what he's saying.
Well, that's my point. I was going to say that he believes what he's telling you, and so, but then again, I always believe what I'm telling you too. So it does. I could be a blatant liar, I guess, as well, or something. I don't know if that's what he is.
Or you could be telling the truth.
Or yes, or you keep telling the truth. And the fact is, we don't have the information to judge him negatively or positively. We have to take it for what it is and let that ride. Because unless somebody comes forward and says, "Here's a government stamped document that claims, that or shows that Bob Lazar is exactly who he says he was," then what can you say? I believe that he had a clearance, because he said certain things during his interview.
You got 1 minute.
Okay.
Thank you.
He said certain things during his interview that led me to believe that he would definitely have had a clearance to say what he said. I know that. I had one for since 1995. All right, nowhere near as high as he supposedly had. So there's more to him than meets the eye, in my view.
Okay, we have less than a minute left, just to let you know.
Yeah, I was just going to say him. I kind of like Travis Walton. They're people that. I take seriously in a way. They seem to believe what they're saying. It's just uncomfortable because what they're saying is so strange. It's so uncomfortable, but very compelling.
Yeah, I think Lazar is more compelling after hearing this than before I heard it. So I'm looking forward to the movie. And I watched the Skinwalker Ranch one, and I wasn't that excited about it.
Yeah,
but the
I
Lazar
agree with
movie,
you. Yeah.
The Lazar movie sounds like it's probably a better one.
Yeah. All right. I think as far as I know, I think we're. Are we ready to go back, Eric?
We got about 30 seconds till intro starts to roll.
All right. So Alejandro, I guess we'll say goodnight for real this time, since I said goodbye to everyone when you were on. But that. So thanks, and we'll talk to you next week.
All right. Talk to you guys later. Have a fun show.
Thank you.
See you later, Alejandro.
Adios.
Adios. Great talking to you.
Hang on just a second. Let me get this. Here we go.
You guys ready?
Yeah.
All right, we got a little bit, about 10 seconds.
All right.
Are you guys ready?
Yeah, ready. Yeah.
Yep.
5, 4, 3, 2, 1.
All right, welcome back to the show. I'm here with Marc D'Antonio, and we are going to be talking about all kinds of great stuff, space stuff. And Marc, so where do you want to start? I have a bunch of different topics I want to talk to you about. You want to start out with space junk, or you want to start out with the landers?
I think that why don't we talk about the most recent thing, which is the Mars InSight lander.
All right, excellent.
Yeah. So, if you're, I mean, if you want, I can just go through some of the basics, and we can, you can. I don't know where you want to go with that. So
yeah. First of all, I know that I always love to watch when they land in the control room, where everybody is just so excited, and rightly so. I mean, it's their baby from from the moment it takes off till it lands, and it's there's so many things that can go wrong, and a lot of times they're unsuccessful, so it's a big deal.
Yeah, I mean, I know that the United States has been more successful than other countries in getting to Mars, and that's a good thing. But we've had our share of failures too. But I can say this: the Mars InSight lander, I mean, that was in space for 6 months, and it all came down to the final 7 minutes. That final 7 minutes, as you've heard them say, I'm sure, and those watching and listening have heard, this was the 7 minutes of terror.
Right.
Okay. And everything, hundreds and hundreds of machine operations and different mechanisms and bolts and explosive bolts and other hardware had to do exactly what it was supposed to do. Not one thing could fail.
That's right. And
it didn't. And as I listened to live, I had butterflies in my stomach because, I'm obviously a big fan, but I think of these probes as if they're actually almost like people in a way, because they are an extension of what we are. Right. And what the InSight lander is going to do on Mars is a spectacular mission, and I really, really want to see it happen. And I was just I was worried, but I was actually confident. JPL has been running on a high ever since Spirit and Opportunity, actually since Curiosity. Okay, Spirit and Opportunity, those landers had a 90-day life expectancy. And they went on for years and years and years, plowing through Martian soil, winter, spring, summer, fall on Mars. And they continued to do their jobs. And Opportunity still continues. If we ever, I don't know if actually we heard back yet from Opportunity. I don't think we did. But Spirit was stuck and mired, and it has a wheel that stopped working. And an Opportunity during the dust storm was lost. So I'm not sure if it'll ever come back, but there's always hope, right?
That's right.
There's listening to it. So,
and let's talk a little bit about what its mission actually is. It's going to be doing sonar or something to do with the crust of Mars. Is that right?
Yeah, actually, there's several instruments on board the InSight lander, which are really cool. First of all, let's talk about where it went. Right, when it landed, and all those many things we talked about went right. It landed in a place called Elysium Planitia, and that is interesting because it's just south of the Viking 2 lander, and it's just north of where the Curiosity rover landed. It's actually closer to where the Curiosity rover landed than Viking, and it has these instruments on board that are designed for very specific purposes. There's a remote manipulator arm that's going to be able to carry instruments off the main body of the lander and drop them onto Mars and set them at a distance. All right. And those instruments, I'll tell you what they are. One is called the SEIS instrument, SEIS, and that stands for Seismic Experiment for Internal Structure. And that's going to be deployed by that remote arm. And it has a little dust and thermal shield on top of it. So it looks like a little bug, a little round-topped bug. And it can detect really small vibrations. And I mean vibrations down to the atomic level. This is probably one of the most advanced seismometers, if you want to call it that, ever made. And there might be liquid moving around inside Mars, and this will be able to feel it. Right? There might be frictional vibration imparted on boulders, many, many miles away or hundreds of miles away that this thing can feel. It'll give us an idea of how the atmosphere of Mars is working, what the internal structure within Mars is, because if there's liquid water down there, it'll feel it, it'll hear it, and it'll be able to look at the rhythmic patterns and figure something out based on any rhythmic pattern. So if water's sloshing, we'll find it basically. So the weather systems also cause vibrations in the atmosphere of Mars, and these vibrations are something that are also highly important. That'll tell us, a lot tell us more about how Mars works, because we've been there, we've drilled a little into the soil, but we haven't done anything like this is going to do. Okay, because this experiment, it has an experiment on it called the HP cubed experiment, and that stands for heat flow and physical properties probe. So P cubed. So the heat flow and physical properties probe is going to be deployed by the remote manipulator arm, a separate little unit. These are both the seismic deployable system and this HP cubed experiment are going to be connected by little ribbon cables back to the main lander. But this one is the heat probe is going to actually drill down 16 feet into the Martian surface. 16 feet. I mean, but keep in mind, the InSight lander is the size of an old, convertible station wagon. Okay, I mean, or convertible rather, like a 60s convertible. It's not small, and each of the solar panels are like 7 feet in diameter, and it has two, one on each side.
I can't even imagine how they could coordinate, like the assemblage of a drill bit, because obviously it's not a 16-foot long drill bit. It has to be put together somehow.
Yeah, there's actually the system is really complex, of course, and it's going to be going down and basically hammering itself down into the surface. Okay, and the idea is to get it 16 feet down. And why would they do that? Well, it's going to go down, and what it's going to do is detect something very important, and that important thing is checking the heat that is actually escaping Mars. All planets that have some type of solar impingement, that is to say any solar energy striking the surface, are going to give off some heat. It's going to get absorbed into the interior of the planet, and then the planet's going to give off some of the heat. So that's one. The second thing is if the core of the planet is still semi-molten on Mars, all right, then you're going to get some heat that's given off by that, and that's going to end up getting out of the crust eventually. And that's what this experiment's designed to look for, is to check the heat being released by Mars. Now, very important stuff. Now, we've talked on Sky Tour Radio, and Amanda Curran, my co-host, knows all about this. It's one of her favorite topics. We've talked about a special way to get Mars to terraform itself. Now, we know that our planet has a magnetic field. The magnetic field is what keeps our atmosphere basically intact. Mm-hmm. Otherwise, the radiation would destroy it. Well, on Mars, that did happen.
Right.
And there was no magnetic field on Mars to speak of, and the atmosphere was a lot thicker, but it was destroyed over time. So what we have to do is restart the magnetic field of Mars. Well, how would we do that? Well, we could restart the core, basically. If we get the core to be molten again and the outer core and the inner core of Mars rub against each other, they'll create electric currents, which will create a magnetic field. But guess what? That's probably far beyond even an advanced species. So what else is there? Well, we could use the fact that there are points in space around Mars where all the gravitational forces basically sum to zero. So there's like parking spots in space. These are called Lagrange points.
Oh, yeah.
If we can, right. If we can put a unit out there from Mars at the Mars Lagrange point number 1, which is between Mars and our sun, a few tens of millions of miles from Mars, then if that was a magnetic field generator of some kind, all right, then the solar energy striking the magnetic field would actually drape that magnetic field behind this magnetic field generator. And also, if Mars was close enough, then it would drape it behind Mars as well. And it would actually basically coat Mars with a protective sheath of a magnetic field on that downwind side, basically. And we're talking about solar wind, high-energy electrons and protons that are making their way to Mars. And those bombard the atmosphere every single day and destroy water vapor that's in the atmosphere. Well, if we can shield Mars from that process artificially with this magnetic shield, and it's actually a real project on the NASA docket, by the way, is a magnetic shield for Mars. If we could do that, then we would find that we'd have a Mars that is a lot more conducive to letting the water vapor stay in the atmosphere. And if that happens, it'll get warmer. and the polar caps will begin to melt. The CO2, the carbon dioxide parts of the polar caps will sublimate and go away and become carbon dioxide, making the atmosphere heavier with this greenhouse gas. And that will make it warmer again, and the water will begin to melt, the water ice, which there's a lot of on Mars. And if it melts, then we can have a thicker atmosphere. And if we have a thicker atmosphere, well, then you see Mars is terraforming itself, because Mars generates water vapor all the time. It's just destroyed, by the ultraviolet radiation that's impacting it from the sun. A magnetic shield would prevent that, you see. So we actually see a way to actually do real terraforming at Mars, and we don't even have to touch the planet.
Amazing. I'm going to ask you a hypothetical. I know no scientist likes to answer a hypothetical, but now we do know that there's signs of water and possibly a lot of water on Mars at one time, and flowing streams or flowing rivers, or there's stony brooks. I mean brooks. What am I trying to say? Brook stones. Smooth over stones and everything from running water. The hypothetical is: would you think that it's possible that there was life on Mars or not at one time?
Actually, I don't think that's too far-fetched. We talk about microbial life. Advanced life, I would probably say not enough time. Look at what happened here. We were kind of in the quote-unquote perfect location, and yet our planet is still far from perfect. We've had 5 major extinction events that have killed a lot of life on this planet, up to 96% of it at one time. Okay, and yet we survived. We persisted. A couple 100 million years ago, the Permian period was in full force, and mammals, like we are, were dominant at the time. But then there was this great dying, and 96% of the species died. But dinosaurs, the reptiles, the larger reptiles, they were relatively unaffected. And this started the age of the reptiles. That's why we had dinosaurs on the planet. And then when the 65 million years ago, when the Chicxulub event, or the Cretaceous Paleogene event it's called, the death of the dinosaurs basically, when that asteroid struck the planet, that caused the reptiles to go into retreat. And now those mammals that were hiding in the shadows for millions of years were able to come back out. And again, we achieved dominance and became what we are. On Mars, that process, would have taken a lot of time, just like here.
But how do you know there was any extinction events on Mars to say that there was, animals on there at one time? We don't know. Or creatures.
Yeah, we don't know, but we do know that given the time frame, Mars is about as old as the Earth, basically. And so we look at the fact that over hundreds of millions of years, life developed on this planet. I mean, if you look way before the first Cambrian creatures were in the Cambrian oceans, okay, we had probably 2.7 billion years ago, we had blue-green algae basically on the planet, cyanobacteria. These bacteria were gobblers of carbon dioxide. Well, they could have existed on Mars. I don't see any reason why they couldn't. Why? Because the universe creates a template for carbon-based life. Okay, meteors deliver carbon-based compounds. Comets deliver carbon-based compounds. Asteroids deliver carbon-based compounds and water. Okay, along with comets. So the carbon-based life form is actually sort of a predestined type life form that you might see. And I say might because we can't be sure of certainty, right? And on Earth it happened, so why couldn't it have happened on Mars? Mars at one time was a warmer climate. It was actually a more well-developed planet. It had a magnetic field until the core of Mars began to cool enough so the magnetic field was no longer effective, and that's when everything happened. That's when the atmosphere began to thin because of ultraviolet radiation, killing the H2O molecules. It would split them apart. The hydrogen would get lost to space, and the oxygen atoms would actually go down into the soil and bond with things like iron to create FeO, which is iron oxide, and that's rust, and that's why Mars is red.
Right,
see?
Yeah.
So that you see a chronology here. Now, there was a lot of water on Mars, no doubt. And people say, well, where is it? Where is it? Well, we're seeing this at the end of the cycle. We're seeing it at the time when Mars water is now locked up subsurface in ice hard as granite. And we're seeing it at a time when Mars is at a point where it doesn't have an atmosphere that is thick enough to allow liquid water on the surface any longer. However, we see evidence of liquid water even in recent years occurring on Mars, mostly in the sides of deep craters where suddenly, right, you know this, that there's a burst of water that comes gushing out of the side. It's probably very salty, and it goes racing down the crater interior toward the bottom of the crater. But as it's falling, it's also sublimating. It's going away. And when it goes to from that when it goes to water vapor, then the water vapor is destroyed by the ultraviolet radiation. So this and then of course it leaves the salts behind. So this is what we see on Mars now. Okay, we don't see standing water except at the South Pole, and it's down, I think, about a kilometer below the surface. There's a 12-kilometer long actual subsurface lake near the South Pole of Mars.
Wow.
That's very important because that's telling us that there's actually actual real standing water, and that there's a place where the warmth from the interior of the planet it's warm enough so that the pressure from the overlying rock strata, the warmth coming from the core radiating out to those rock strata is enough to allow liquid water to form. And that's the pressure of the overlying rocks, which are providing the pressure and the mass, basically, and thus the weight on Mars, to allow for that water to exist as water as we know it. It's just an interesting, it's perplexing at all the new things we're learning about Mars. It's just absolutely incredible.
There's a question related to that, Daryl from YouTube. And thanks again to Amanda for giving me these questions. Daryl from YouTube wants to ask, Mark, didn't one of the Viking landers have such strong results from a test for life that they disregarded the results? Have you heard anything about that?
I actually had they're this thick. I'm making a gesture for like 2.5 to 3 inches. I had all the results of the Viking landers, and I pored over them for many years. And that experiment they're talking about was one, I think, where they were baking some minerals in an oven, and based on what they were on board the Viking, because we had like a little easy bake oven basically inside of the Viking, and it would cook these elements to try and these minerals and try to see what comes off. Now, here's what happens. Typically, just like on Earth, certain minerals can only form in the presence of water. So they look and they gauge how much of a certain mineral is present, and that tells them how much water may have been present. Okay, we do that on Earth. When we look back and we figure out how much water we had, how much oxygen we had, etc. Well, on Mars, when they were doing this experiment, there were some results that seemed like they might have been an error because the results were so promising. Now, I don't think that it's necessarily an error, and guess what? NASA doesn't think so either, and that's why this Mars InSight lander landed just south of the Viking 2 position.
Oh, is that right? Wow.
Yeah, it's farther south than it is from the Curiosity position. Curiosity, if you recall, it found these wonderful little round spheres. Now, people have to understand that when they look at pictures from Mars, they're in false color, except for the ones that are just all kind of a salmon, ruddy, red color. Okay, Mars doesn't have a whole lot of color other than the red, and that's something that. So when they look at these little spherules that they found, they called them blueberries. Now they were blue because of the fact that they were formed in the presence of water, but they were false colored. They were false colored. That wasn't their real color. They looked like little pink nodules, but because of their mineral content, they were marked as blue. Okay, so it was sort of a algorithm that painted them that way based on their mineralogy. So we're not looking at a real color here, and that's why sometimes the photos showed blue sky, and that brought all the people that said, "Oh, look, Mars really has blue sky. It's really, they're hiding it from us." It's like, oh my gosh, to what end? If Mars had blue sky, we would have just said, "Hey, Mars has blue sky." Yeah, there's a lot more that goes into this. What's interesting is at sunset on Mars, the sky is blue. Okay, at sunset. All right, which is kind of cool. Usually at sunset it's red here, right? Well, on Mars it's more blue. Okay, and it's for the opposite. It's for the similar but different reasons that the sky's red at our sunset. So,
How about that?
Yeah. So anyway, InSight landed relatively south. It's sort of near the Martian equator, in Elysium Planitia, and Viking was north, obviously, but it's on that side of the planet. It's in the same relative region as Viking too. So it'll be interesting to see what this thing turns up, and that heat flow probe is going to be very important too for when it drills. Now, then there's more instruments on InSight than that, but still, it's really cool.
That'd be really interesting to know whether there is a heated core. There should be. I would think there would be. But whether it's
some heat, yes, but is it molten anymore?
Yeah, is it molten? Is it moving at all? I know without the electromagnetosphere, it's possibly not moving at all. Now, I do want to say that we're talking about Mars. We're going to go into some other things, but we have and the reason I'm saying that is because we are getting some questions from YouTube that Amanda's passing along. But I'm only going to ask the ones related to Mars right now. We have about 4 minutes to a break. Before I ask this question, I just keep forgetting to let the listeners know that upcoming shows I have David O'Leary from Project Blue Book. He is the creator of that for the History Channel. He's going to be on if you're listening to YouTube, he's going to be on December 23rd, along with Dave Marler. That's for a full show, and but that will be our Christmas show. So that'll be released during the day of Christmas. And we have next week we have a professor of history talking about UFOs. It should be interesting. So one more question before 4 minutes we go to break. Drasta from YouTube asks, what if Mars hasn't always been in the same orbit as it is now? That's interesting.
Yeah, I mean, there are signs of massive impact on Mars, just like on the Moon and on Earth. But if it changed its orbit, that would actually have been very drastic. Usually when a planet is in early formation, it might form a little farther away from the star, and then through impacts with other objects as it's accumulating more mass, it might actually slow down a little, or it might change its momentum, as it's called, its speed of motion. And when that happens, it might start to spiral a little bit toward the star and maybe pick up another stable orbit. I think that if anything, Mars would have been a little farther away before it was closer, and not the opposite way around. But, a planet's a really massive thing, and it would take an awful lot of stuff to get in the way and cause it to slow down in its orbit. And generally that usually happens, from what we see, in the very formative stages when it's first forming. So it may have formed a little farther out and then kind of spiraled in as stuff was impacting and accumulating on it. That's very possible. But I just think that Mars probably is in relatively the same location as when it was formed. But that's a good question, because it makes people it helps people understand that planets don't always end up in the same position that they were when they started. We see planets like that now, exoplanets. People know I'm an exoplanet guy. When we look at exoplanets, we know that there are some that are actually spiraling toward their star, and they're impossibly close to the star to have formed there. And what they're actually doing is evaporating because they're too close to the star. And
wow.
Yeah, it's crazy stuff.
Now, as far as I know that there are several possibilities or reasons that we go through ice ages. And one of them is if the sun is quiet, or dimming or whatever. I've heard that. So would you think that if Mars was terraformed in that particular case, do you think it went through ice ages just like Earth in those situations?
Well, if the sun was responsible for cooling the Earth, I mean, we've had a couple of times in our past history where we think we had what's called a snowball Earth. Global glaciation, the entire planet like an ice ball. And that was way before we built up enough atmosphere to actually be a contender in the planetary arena. So, but still, snowball Earth is something that was hypothesized for our planet. So could it have been that there was a snowball Mars? Well, if Earth was that cold, caused by the sun, then Mars would certainly have been cold as well, even colder. So I would imagine that Mars suffered the same types of effects long term that the Earth went through when it came to that kind of coarse view of things. Like we had a couple of global cooling events on Earth that were the result of impacts too. Well, we can't say those happened on Mars the same time, the same way. But the global ice age and the global glaciation that occurred here, if it was due to the sun, well, then the sun changed for Mars too. So it would have changed there.
Excellent.
But,
okay, well, we're ready to go for break, actually. And when we come back, we can take calls. And also, we're going to be talking, I want to talk space junk because that's fascinating to me.
Space junk is fun.
Yeah. All right, everyone. So I'm on with Marc D'Antonio. This is Martin Willis with Podcast UFO on KGRA Radio. And we'll be right back right after these messages.
Clear.
All right. How many minutes do we have this time, Eric? 4 minutes?
You got 4.5 minutes.
Okay, excellent.
4 minutes, my bad.
All right, no problem. So during this break, Mark, we had a ton of YouTube questions come in. So let me fire away. I'm going to start in order, so that's the fair way to go. Let's see. Kim, these are all YouTube questions again. Kim, and why don't we kind of fire through them and not take too much time because we have 4 or 5 of them. Kim wants to know, what is your favorite telescope? Like, say, brand of telescope, I would guess. Yeah.
Okay, well, I can answer both of those questions. My favorite telescope forever is going to be one that's not even up there yet. It's the James Webb telescope.
I saw that at Goddard. Yeah, when they're working on it. Yeah.
That's going to be one to show us the atmospheres of exoplanets, and it's going to be able to do things by looking at the reflective, we'll call it the reflective index of these planets. And Carl Sagan is the one that actually suggested this way back when the Galileo probe left the Earth.
Wow.
We generated a database of reflectance, it's called, reflectance, on planets like our own. And we looked at what a lush rainforest looks like in this reflectance index. We looked at what a desert looks like in this reflectance index. And we made a database, and it seemed like it's pretty darn consistent. So if we're looking for things like plants and lush forests, we should be able to get a reflectance index using the James Webb telescope of these exoplanets, thousands and hundreds of light years away even. And if we can do that, we'll be able to actually tell or get an idea anyway of whether they're actually full of plant life. And that's just the whole thing right there. So,
and what's your favorite telescope that you can use? Like, to say an amateur out there wants to get into star watching.
Yeah, I think that the Meade family of telescopes is reasonably priced. I have a research quality Meade in the observatory, and we'll be using it tonight actually after you and I talk. And it's going to be a fully remote operation tonight for the first time, so we're going to see how that goes. It could go nowhere, it could go everywhere, but we'll see what happens. Okay. On top of that, the Meade telescopes don't have to be research grade. You can actually use one. There are simple ones that are $300 and $400 a piece. They're absolutely just beautiful, and they actually have a computerized for like $400, $400 to $500.
That's it.
You can buy one that has a computer control, so that you can actually. Yeah, it's called the go-to mount. You can actually go to what you want it to. Now that requires that you learn a little bit about alignments and stuff, and how to align the telescope properly to the north celestial pole. But you know something? You could do it with one of your kids in an afternoon, and it's really cool, to learn about the alignment. And then at night, you go out there and say, wow, this was so cool. And then to maintain that alignment, you just put little marks on the ground where you had it sitting, and make the orientation the same every time, and you'll have it.
We have 6 questions now we have to do in a minute and a half.
All right, go ahead.
Okay. Tom from YouTube wants to know if you're still making models or just doing radio these days.
No, I'm doing models. Actually, I'm doing one for the Navy. It's right across the shop from me right here. So I'm doing plenty of models still.
Okay, we have 20 seconds actually.
Daryl
wants to know. I'm sorry, we already did that one. Tony, I guess. Do you think NASA will use Mars thermal heating to colonize Mars outside of a Mars base?
I think that the whole point of putting that magnetic shield project on the books is to suggest that down the line we are going to colonize Mars. We are going to wait for it to terraform itself. We'll see a difference in just a few years on Mars, believe it or not.
Eric, are we ready to go back?
We got about 40 seconds.
Okay, 40 seconds.
So give me another
one. One more is Ronald wants to know, what effect will the Phobos impact have on Mars?
Phobos impact. Phobos is one of the moons of Mars. I'm not sure what Ronald means by that.
I'm not sure. Oh, maybe does it have an impact on as a moon? Does it have an impact on Mars? Like we have a tidal impact from our moon.
It's very slight because Phobos is very small. So is Deimos, the other moon. They may be captured asteroids. So they have fairly low mass, and they don't have a significant.
Okay, here we go.
Intro's rolling. In 5, 4, 3, 2, 1.
All right, welcome back. I'm Martin Willis. My guest tonight is Marc D'Antonio, and we are going to jump into talking about space junk because I think it's fascinating. We have something like 100 million or so pieces of space junk flying around, and so I have a bunch of questions I want to ask you about space
counting all the nuts and bolts that got loose from astronauts over the years. Yes.
Yeah, that's right. There's a spatula up there. There's all kinds of. There's a spacesuit flying around, space blankets. There's objects the size of a bus, all the way down to flakes of paint. But I want to first of all ask you about the danger. It seems to me that putting anything up in space is a great danger when it comes to something that's actually moving at, I want to say, 4 miles per second.
Yeah, I mean, when you talk about penetrating the atmosphere and heading up into space, I mean, we take off and we head off in the in a direction that lets the rotation of the Earth help us with our motion. So we start off with about 1,000 miles an hour to begin with. And now we're up there, and we have to go to the space station. It's just over 250 miles up. We got to be moving at 17,500 miles per hour.
Amazing.
Okay, and when you saw that the beautiful, fragile-looking gossamer solar panels on the International Space Station, and then you saw that video of the space station passing in front of the sun that was captured by a very intrepid astronomer, you saw that it went over the whole sun in just a split second. Boom, and it was gone. That's how fast it was moving across the disk of the sun. So when you look at something like that, you think, wow, how could that move so fast and not fall apart? Well, it's because it's not feeling any inertial forces. Now, however, what's an inertial force? An inertial force is a force that is basically based on the mass of the object. So a paint flake is minuscule. And if someone dropped paint flakes on your head from 10 feet up, you'd say, hey, cut that out. But if those paint flakes hit you at 17,000 miles per hour, they'd cut right through you.
Sure.
Like razor blades.
Yeah.
And that's the thing that is always a worry. And so NASA tracks objects in space. It tracks objects in orbit. It tracks objects that have been destroyed. There have been actually collisions between objects, satellites that have occurred, and it's actually somewhat rare. And there's actually been satellites that have been blown up intentionally.
Right.
I referenced the Brilliant Pebble, Star Wars project, which, that particular project, they said it never got done, but it did. And that particular project, littered space with a bunch of debris, and there's no knowing which way that actually went. That cloud of debris, when something strikes another thing, all bets are off. Every direction, every angle is going to have a piece of debris flying through it. And then it's going to slow down. Some of it's going to re-enter the Earth's atmosphere, but some of it's going to go up higher, or some of it's going to go along further in the same orbit, higher orbit, lower orbit, a little bit. And, over time, those kinds of impacts will tend to clean themselves up. They'll tend to clean themselves up. The debris will tend to re-enter the Earth's atmosphere. It'll tend to do that. It's not just going to stay there forever in the same place, like a big cloud of debris, because it's very, very difficult to get something in a stable orbit around the planet. So only a very, very little bit of that junk will actually be in a stable orbit from, say, a collision or an explosion. All right. So, but the things that have been up there that were things that were already on orbit and then accidentally dropped, and they couldn't reach for them in time, couldn't grab them, and they kind of floated away. They're moving at the same relative speed that the space shuttle or the space station that dropped them, and that's going to not. That bolt now is a projectile and could rip right through a satellite or through a rocket or through the Orion spacecraft when they're launching to Mars. They have to be absolutely careful to the nth degree because they're taking off through a cloud of debris, basically. It's not. I make it sound like it's everywhere. It's not everywhere. It's in fairly well regulated areas, and they know where most of this stuff is.
But it's going in all different directions. That's what I just can't understand how they can track it. And another thing, is there ever any? I mean, it's going to get to the point where they're going to have to do something and do a little bit of cleaning. I would think, that would be a great contract to get, wouldn't it?
Yeah, and first you'd have to build the technology to do the cleaning.
Yeah,
because you have to consider that there are satellites orbiting everywhere from just under 200 miles all the way to 22,000 miles away from the Earth. And the ones that are that far away, you don't really have to worry too much about because they're fairly well known. You understand the booster that puts something in geosynchronous orbit. That's going to be, maybe 12,000 miles out. And, you'll see that thing. And if you took a picture of it at night, like we've done in SkyTour Livestream in the observatory, we've taken pictures of these slow-moving satellites and of the geostationary satellites. If you did that, you'd find these things moving all around the sky as well. Again, straight lines. But sometimes, these objects are very elusive. Sometimes they are rolling and tumbling end over end, and they actually might show you something bright and then something that's almost invisible, then something bright again.
I see.
And that'll go on and on until they pass the sun.
Yeah, the reflection of the sun.
Yeah.
So when something's up there, like for instance, 1957, there was a weather satellite launched, and of course it's defunct, long defunct, and it's going to be like 240 years by the time that'll actually come back down through the atmosphere and burn up. Do they ever plan on setting something at a location where it'll actually re-enter after it's expired, or close to the time it is expired, or they just put it up there?
No, actually, I think all space missions now have a terminal plan, and they have a plan for saving just enough fuel, for instance, to cause a controlled re-entry over the Indian Ocean, say, usually, and they do this, and so there's a lot of material up there that has a lifetime, and they don't just leave it up there and say, oh, well, that's stuck up there. They actually put things up there with an eye on their destruction.
Really? That's great.
Yeah.
I think
they do. Now, I can't say in the golden age of rocketry in the 50s, okay, when the Tyros weather satellite went up, for instance, yeah, it's long defunct, but it might still be up there, but it might also, over the years, feel the impact of a few molecules, every orbit of the atmosphere, and that would tend to cause a little bit of drag, and that would make it come lower and lower and lower until finally it would burn up. Well, they actually can calculate how long it would take for an object like that to degrade in its orbit, as it's called, and then that decayed orbit can then be shown, and then people can take a cruise ship to go out and say, okay, well, the satellite's going to be entering right about now, and all of a sudden you start to see it. I mean, it's literally that accurate.
Wow.
Yeah, and by the way, let's go to the southern Indian Ocean where we're going to see it. And usually they'll send a plane up there, and they'll see it from a plane as it re-enters. I mean, it's fairly well planned out, but there is a lot of junk. There's over almost 5,000 active satellites, and many of the rest are either intermittent or are fully defunct, and some are boosters. And I was mentioning the tumblers that sometimes tumble. When I was in Arizona a couple weeks ago, I was there for 10 days. I had the As I said, I spoke for the Phoenix MUFON group, and then a week later, I helped to teach the boot camp in the desert and for MUFON, the Mutual UFO Network. And while I was running a nighttime sky watch, I just happened to point a green argon laser up at a constellation to show people. And right there at the end of the laser, you saw this flash. And at first I thought, oh, I illuminated a bat or something. And then it happened again. I was like, wait a minute, check it out. And I pointed it out. We all looked at it, and it's like, wow, how about that? It was coincidental that I put the laser at it, but some people were wondering whether I initiated some kind of communication.
Of course you did, yeah.
That's what people thought. But the fact is, it was actually a tumbling satellite body, and we could look it up. We found which one it was. I think it was SB-8, and bottom line is that was just tumbling, and it was catching the glint of the sun as it was tumbling slowly in space. And then as it passed over us or passed enough past us so that the glint was no longer visible, then it went away. And I took a time exposure of the area, and I caught it I captured it, I should say, on the digital camera. And we actually have this little faint line of where it was, but it's very bright because it's reflecting a very bright sun,
Interesting. Wow.
Yeah.
Yeah. Space. Another way to look at space junk. It's the history of our technology is floating around there, perfectly preserved, or a lot of it is that, like you said earlier, some of it might smash into each other and kind of vaporize itself and all that. Question earlier, we were talking about the James Webb, James Webb telescope. Would that be able to detect a planet like ours that are with silly people on our, people like animals sending things up into space and causing their own space junk? Would we actually be able to detect that?
Well, I'll tell you what we'd be able to detect. And this is the thing that, when Stephen Hawking said, we don't want to announce our presence, we should really just sort of be quiet and not let them know we're here. Well, and he knew this. Unfortunately, we had no call. We had no choice. Okay, we didn't cause it. It happened 2.7 billion years ago when those cyanobacteria started eating the carbon dioxide and basically pooping oxygen, right? And that's what we breathe, all right, is that waste product from this process. And the buildup of this oxygen atmosphere at our planet is something that is very important because at Mars, we know that when the materials were broken down, the oxygen went right back into the soils and disappeared from the atmosphere almost entirely. And that's what a planet wants to do. It wants to get rid of the oxygen that way. So when we look at a planet like the Earth, if we look at the planet like the Earth from 1,000, 10,000 light years away, if we can see what the atmosphere is made of, we're going to see oxygen. And we're going to know from studying the oxygen atmosphere of that planet that this is no accident. This is nothing that's sitting it's a mature planet. It's circling the sun in a stable orbit. It's in the habitable zone. We know that oxygen is not due to some sudden catastrophic release of oxygen, most likely, but it's something being replenished. And that replenishment is likely coming from a carbon-based template provided by the universe and all the things I mentioned earlier. And that carbon-based template has created some type of life that utilizes this catalyzer, this oxidizer, I should say. And so that is something that would be visible many, many light years away. So the James Webb Telescope is going to look for oxygen atmospheres undoubtedly.
Wouldn't you think, though, pardon me, along the lines of what I just mentioned, wouldn't you think that it would be a way to detect that there's intelligent life out there is to actually see if there's space junk flying around a planet, or you think that's a silly thought?
No, it's not a silly thought. It's just that it's a thought beyond our technological capability.
I see. Okay.
We don't have a way to detect that space junk. Now, we could possibly, if this space junk or active satellites around this other planet somewhere was beaming some type of radiation, we might be able to detect this periodic radiation pulse of some type coming from a planet. For instance, when Tabitha Boyajian discovered the star that was dimming, the notion that maybe it was dimming because a advanced race was building a Dyson type sphere, that is to this enclosure that would completely encapsulate their star and absorb all the energy from it. It's actually one of the postulated thought processes that Freeman Dyson suggested, named for him, of course. But it would be more likely something called a Dyson swarm, a lot of satellites that would beam microwave radiation back to the planet after it captures it from the star. Put up enough satellites, they're going to dim the sunlight as seen from our planet, because they would be orbiting the star, not the planet. Okay, so it's possible that we could see something, but I don't think that we have the ability yet to discern the difference yet. I mean, it'll be enough to, when we get the James Webb up there, to look and see whether a planet has an oxygenated atmosphere. If it does, and it's fairly significant, then that will mean to us there's probably life there of some kind. Maybe. I mean, could it be a volcanic in origin? Could it be other mineralogical processes? Sure, oxygen can be formed that way, but it'd have to be an awful lot of a specific set of minerals to cause that much oxygen if we see it that much. So we don't have that even on Earth. We don't have that on Mars. Yet Mars makes oxygen in a similar fashion. And there's ways in which it happens. There's ways that it happens here, of course. And here, it's the fact that our planet is not, I repeat, not in equilibrium. If it was in equilibrium, then the oxygen in the atmosphere would have found some level that's fairly low and gets absorbed back into the soils and binds with all these other components in the soils. That's not what happened. Here we have something called disequilibrium. We are not a planet that's basically in a state that is balanced. We're unbalanced, and we're pro-oxygen.
Wow.
See?
Hey, Mark, we have a caller calling in now. So let me take the call.
Sure.
Caller, you're on the line. Your first name, where are you calling from? Caller, can you hear me? Well, we do have a caller on there. He or she is being very quiet. And if they call through Skype, they're actually gone now. So, and I'm sorry to have interrupted you.
No, it's fine.
On space junk. Now, someone made a good point. How long do we expect the ISS to be in orbit?
Well, if we leave it alone, it'll come down in the next few years. We have to constantly monitor the ISS because it's a big, broad object, and it is getting hit by stray molecules here and there and stray atoms from our atmosphere. All right. So we do have to monitor that. So it would come down in a few years. I think they have funding through, and I could be wrong on the date here, but I think through 2028. I think they have funding. Now, if you consider what's happening, we're putting up new stuff like, we got that new inflated tat, as I call it, that Robert Bigelow put up there. I think that's the future. I actually believe in Bigelow's mission with that, because I think that putting an inflatable habitat on Mars or the moon, moon first, I think, is probably a better idea, is something that's going to really pave the way for being able to have cheap housing and habitable areas. And if you put those underground, then you have the protection from the ultraviolet, say, on the moon, and, of course, on Mars still at this point.
Just a couple more questions about space junk. And then we'll move on. I'd like to talk a little bit about, you just mentioned the moon. I'd like to talk about the Chinese moon lander that just landed. Do you know anything about that in particular?
Is that the Chang'e? Chang'e 3?
I think that's the way it's yeah, so if you answered that, then you know something about it. Sure.
Something.
All right.
Well, so I thought it was a really interesting lander.
Yeah, all right. But before that, I want to ask you just a couple more questions, or one possibly only. How dangerous is space junk? You think about most of it gets burned up in the atmosphere. And by the way, if it gets burned up in the atmosphere, and is there any way it could still pose some type of problem as far as poisons or anything like that? Or once it's burned up, it's just nothing to worry about?
Well, I think that only for the local environment where it hits, like if hydrazine tanks are corrosive, hydrazine's a corrosive material. So the likelihood that there's hydrazine still in a tank when it hits the ground is fairly high if it went through some kind of circuitous reentry pattern where it didn't really get the same kind of heating, if it wasn't breached, okay, if it was still like a spherical tank and the valve was closed at the bottom, well, then maybe there could be something in there, but it's really toxic. So I think that's true. Now the bigger question comes when you talk about launching nuclear satellites. Okay, we had Cassini. Okay, Cassini was nuclear powered, I think, and so was Galileo, I believe. And if those failed on launch, then they had to have procedures in place such that the rocket that comes crashing back to Earth with this satellite with a nuclear power core in it would not cause any kind of breach. So they had these special containment vessels inside these satellites that were literally they were tested so much to prevent breach. They tried everything, nothing would breach them. So they figured, okay, they're safe. In an accident, they won't breach. So it's really the nuclear stuff we have to worry about more, I think, because just look at Fukushima.
Right.
Look at Chernobyl. Let's actually look at Chernobyl. Okay, Chernobyl was a deadly accident, and that core. What people don't know is that core was that melted core in that graphite reactor was actually melting through the containment building. And it was thanks to an American team, right, that meltdown was stopped. And you can thank the scientists at Lawrence Livermore for that. And when that occurred, had it gone through the containment and gotten into the water table just below the building, then we would have this erupting steam volcano, radioactive steam volcano, that would have gone on for tens of thousands of years.
Wow.
Yeah. And that would have cost hundreds of millions of lives over time. But because, it was a project that was classified and the Russians asked for help, the people that saved hundreds of millions of lives couldn't be acknowledged. And that's actually that's a true story told to me by the actual scientist who created the solution to the problem.
Yeah, I know it's way off topic, but it
is.
But no, I'm saying Fukushima still really worries me, and I don't think enough people. I think that's so far out of the news, but it's still a real big deal.
Well, yeah, that's why I'm saying, I'm more worried not about hydrazine and fuel. That can always be cleaned up. You can't just go clean up a nuclear accident.
Yeah.
So if there's a nuclear spacecraft, that's a big problem. We do have to worry about that.
Right. And hasn't, since you're talking about satellites, hasn't Kepler been basically decommissioned in space at this point?
Well, the K2 satellite, let's call it that, because Kepler was the first mission, and Kepler was launched in 2009, March of 2009, actually. I remember it. I was so intrigued. I couldn't wait. And it looks up at an area the size of your fist extended at arm's length at one spot in space.
Yeah.
And they have these reaction wheels, these discs that spin, and they actually cause momentum to be balanced, and that combination of spinning discs on the satellite cause the satellite to have a ability to be moved in any particular location very, very precisely. Okay, well, it can run on 3 and it had 4, but it lost 2.
Right.
So it only had 2 left, and so Kepler was announced I think around 2015. It was announced to be dead, but then engineers said, "Hey, wait, the solar energy hitting the Kepler Space Telescope is also a force to be contended with, and we've always been dealing with it. What if we reprogram those reaction wheels to respond to the solar wind that's hitting it? And then we'll have our third reaction wheel back, kind of, sort of." And they said, yeah, let's try that kind of, sort of. And that kind of, sort of was a brilliant success. And then that found an additional 23 or 2,500 planets, on top. So we're talking a major success. But then they still need a little extra fuel. They needed to have some fuel that wasn't, electrical from solar and wasn't from the reaction wheels to actually do some of the tasks to orient Kepler. And unfortunately, when that ran out, Kepler and Kepler 2, the other re-engineered Kepler mission, did have to come to an end.
Right. Yeah. All good things have to come to an end. So Kerry sent in this question through email, and he wanted to know, as an astronomer, what are your thoughts on Stephen Hawking's hypothesis that black holes could be gateways to another universe?
Well, that's a loaded question, man, and I'm really grateful for that question. It is sort of different from what you wanted to talk about, I'm sure, Martin. But you know what?
Oh, that's all right. No.
As far as being gateways to a different universe, we don't really know what's inside a black hole. We just know what's not inside a black hole, and that's the rest of space around it. We know that if the sun were to become a black hole tomorrow, and it can, it's not massive enough, but if it did, let's just say, the planets would just continue orbiting like normal, because a black hole is basically is created by the amount of gravity that the original star had. It's just that it's focused onto a small, infinitely small point, basically, which of course people can't comprehend what infinity is, never mind a singularity that is an infinitely small point. But that said, my feeling is that it's possible, but probably not probable. I mean, I think that we're probably talking about parallel universes, multiverses, before we would talk about and I'll tell you more about that. And I don't think black holes are the ticket to get there. I think that there's a number of ways. It could be interdimensionally, or it could be kind of like the soap suds theory, where if you pour some Dawn dish detergent in your sink and run the sink really loud or really hard with hot water, you get this big froth of suds. But what if each of those suds, those individual suds, was a universe? Okay, that's one of the theories, and each of the suds next to it is connected to it by a flat wall, a flat facet. And that flat facet of the edge of that bubble, for all the interior bubbles, the universe would have flat sides. For the outside one, they might have somewhat circular outsides, and that has to do with the law of minimal surfaces, and that, which just means, it had to take up the least amount of space possible. It's going to, create a little round object near the outside, but inside it may not. And so maybe our universes are like this, where they're all linked together with these flat walls. So how do you get to another one? Well, is it necessary to go through a black hole? I don't think so, because black holes are actually the result of supermassive stars that are undergoing collapse, either after supernova or during. So the fact is, those happen a lot of places all over the place, and they usually happen within galaxies. So I don't think they could be gateways per se. I think they are a physical, I was going to say ailment, but it's not really an ailment. I think they're just a physical property of the universe and massive stars. But if we could get to where the flat facets are, if it's the soap suds universes, then we could probably just go through at that point. And there was a spot, by the way, and I'll just say this to end with this, and to end that part of the question. There's a spot in the universe where there was some matter that was streaming out of the universe. And I say out because we don't know what out means here, but the matter seemed to be streaming someplace that wasn't our universe, and we don't really know where it was going. But it wasn't going through a black hole. It was just streaming. And so is it possible that if the soap suds theory is correct, that maybe the facet had a hole in it and stuff was streaming from one universe to another? Why would it do that? What was happening? So that's sort of far-fetched. There's more science back there that indicates maybe that wasn't happening. But what if we're interdimensional? Well, now maybe what we're seeing when people see, for instance, ghosts, maybe they're actually seeing what I've coined a term, a parallel universe intersect. Maybe they're seeing these parallel universe creatures or beings in a way that makes it look like it's nothing you can touch here. It's not a tangible item here. But maybe to that creature on the other side of the dimensional universe, we're the ones that are not tangible to them. So, I'm not sure. There's an awful lot of science that we do not know, and it would actually be arrogant of me, I think, to actually try and say that it's one way or the other. So I just tend to err on the side of thinking that black holes probably aren't the conduit, because they seem to be happening all over the place, and we recognize them as collapsed stars, and the physics tells us different things than what a conduit to another universe might. Long answer, sorry.
No. I love long answers on a 2-hour show. So Persian from YouTube wants to know what you think of the lunar wave anomaly. I'm not familiar with what that is.
Oh, I'll tell you what it is. All right, in my view, I've seen a couple of lunar waves, and I saw them on P&K Space Imaging as well as other sites. And here's what happens. The lunar wave is not an indication that the moon's a hologram. The lunar wave is not an indication, and I can say this with certainty. Okay, the lunar wave is not an indication that there is some kind of strange, NASA kept secret hovering over our heads. What it really is it's the effect of a physical atmosphere over our head. Now, what do I mean by that? Well, if you look online and you say that you want to see, go to Google and say, I want to see all the jet traffic currently in the air, you will find that there are tens of thousands of flights in the air at any one time.
Right.
It's amazing. And now, what do those do? Well, those will actually heat the air. All right. Jet exhaust is hot. Okay. And it heats the air. And by the way, a jet doesn't always leave a contrail. Okay. It leaves a contrail generally above 30,000 feet, but below 30,000, you're not going to really see a contrail. Okay. So when a jet's taking off, or when a jet is climbing, it's going through 25,000, it's not going to leave a contrail. And as it passes through the air, it heats the air behind it. And that air doesn't just sit there. The air is part of a big stratified band of air, okay, called an air column. It's actually moving across the surface of the Earth. And so sometimes those air columns drift across the face of the moon. All right? Huh. And when I say column, I don't mean jet exhaust column. I mean giant slabs of air that have a heated line of air through them caused by the jet. Now, these things will last anywhere from a few seconds to many, many minutes and possibly even an hour, depending on the conditions. So as the jet goes through the area, it could be long gone, but the remaining warm air, and it doesn't have to be much warmer, okay, drifts across the moon. It stays kind of in that location because it was in an area of the sky that's sort of still, right? And that is to say, still relative to each other, relative to each molecule around it. The giant slab of air, though, could be moving at tens of miles an hour, like the jet stream. The jet stream moves at giant, at sometimes like 80 miles an hour or more. Well, guess what? If you're in a balloon in the jet stream and you leaned over the side of the balloon, you wouldn't feel this blasting wind in your face. Okay. In fact, if you dropped something, like say you dropped a piece of paper, it would flutter down, just like it does on the ground. It would flutter down, and it wouldn't go whipping away from you at high speed. It's because you're all moving at that same 80 miles an hour. Mm-hmm. So relative to the rest of the world, that paper is going to fall just gently. So if you think about it that way, and think about these contrails or these heated jet exhaust pathways as an area in the sky that's actually going to stay fairly cohesive for a little while until it cools, right? Then you're going to find that you'll see this line drift right across the moon. And I've seen that, like I said, a couple times. And one time on P&K Space Imaging, where Paul and Keith were doing their magic. Paul in Miami, Keith down in Pennsylvania. So when they were doing their magic, it was actually really, really interesting to see this. And again, this is just a physiological artifact created by aircraft creating warm lines of air that then drift across in a cohesive manner. And they're not uncommon, actually. It's just uncommon for them to pass the moon.
Isn't that something? I never even knew of that or heard of that. We do have a caller on the line. Caller, your first name, and where are you calling from?
This is Malcolm from the mighty metropolis of Punta Gorda, Florida.
All right. Thank you for your patience, for hanging in there. You have a question for Marc?
Well, I noticed he's got quite a career. His work in special effects and everything. I wonder if we could change the conversation a little bit. I don't know why people haven't pursued communication with the marine mammals to understand other intelligences better.
I can actually speak to that because for a period of time I was debating whether I was going to get a degree in oceanography or in astronomy.
Oh, really?
Yeah, I was either going to go inner space or outer space, and I chose outer space. I think primarily because The thought of being on the ocean, I get seasick, and I knew I'd have to spend a lot of time on ocean-going vessels and doing research, and I was afraid that I would get embarrassingly seasick. Frankly, it's a real stupid reason, but that's actually the truth. I was actually very interested in dolphin communication in particular, because dolphins have a way of communicating. And, when you look at the size of a dolphin brain, you say, oh, well, it's almost the size of the human brain. Are they just as smart as us?
It's larger than a human brain.
Well, yeah. That's what I mean.
Larger.
Yeah, it's almost the same size as ours, right? But you're right, it's a little bit larger. But, see, it also has specialized organs in it for sonar and stuff as well that are operating that. So that's a little bit of a reason. But
it also has a region called the
paralimbic
lobe, which our brains don't have at all.
That's right.
And it's
that's
an area
we're not
where there are their emotions are sort of integrated. I don't know, integrated with their body or something. I don't understand it.
Yeah, no, I know what you're talking about, and basically, the evolution of the dolphin is very different from ours. They may have brains that are like I said, nearly our size, a little bigger, like you say. But the bottom line is that they didn't have the environmental pressures to do what we had to do. We had to leave the water, and when we left the water, we had to take the ocean with us. That's why you're salty inside. That's why your skin is salty. That's why you have sodium in you.
They left the ocean, and then they came back to the ocean. They evolved from a land mammal.
Well, they actually have their forward flippers do have what look very much like the metatarsals of a land mammal. Yeah, that's correct. But I was talking about humans at that point. I don't want to go down the dolphin evolution path at this point, but because that's not the dolphin, I think is the one we need to look at. There's another animal in the ocean which is, I think, far more intelligent and has a capability of doing very, very powerful reasoning, and that's the octopus. I think the octopus is probably the most intelligent animal in the entire ocean. I've watched a number of tests done with octopi, and these things reason out. They're not fooled by a glass wall. They know what the glass wall is. And here's the other thing that happens. An octopus that goes through this maze of tubes and finally gets his way out into the main tank. The next octopus that follows him, he goes through the exact path without retracing any steps, without losing it. If the first one gets through, then the second one gets through. The first one takes, say, 30 minutes, 40 minutes to actually figure out, goes through all the dead ends. Then finally he goes through the right path. The second one is watching. He goes right out the correct path. There's something to that. Now, here's the thing. The octopus doesn't know he's on the right path until he gets out. So he can't be leaving any kind of biological tracers behind to say, oh, this is the right path, okay, because of the fact that he doesn't know he's going to get out until he actually gets out. The second one says, ooh, I know where you're going. I'll be right behind you. This is very much like humans do. We watch someone do a task, and we can repeat that task pretty much. Now, so the octopus is very, very intelligent. And if there was ever an animal, and I'm not trying to say it was, if there was ever an animal delivered to this planet of an alien nature, it's probably the octopus.
Interesting. Hey.
Yeah, I've heard about that, and you can trace cephalopod evolution, I guess, back to the Nautilus, and that's the most primitive. And then it takes this leap somewhere, and you come up with the octopus, which is a much more sophisticated creature.
Very sophisticated. The chromatophore, the way it changes color, can blend with its surroundings. That entire process says, I understand my environment. I understand my environment better than the other creatures around me that might want to eat me. And I'm going to change how I look to blend in. There's a conscious reasoning going on there. And that's the thing that I'm just so amazed with those. But anyway, I don't want to digress and go down that path. Obviously, we're talking about space junk and the Chang lander and so forth on the moon.
Yeah.
That was a great question.
I'll just leave you with the thought that in human beings and in dolphins, there's been a case of convergent evolution regarding their emotions.
Yes. Yes, I know that animals can
because
they show that kind
even
of
though
motion.
dolphins are physically very, very different from us,
Yeah.
they've evolved the ability to make and fully experience very deep bonds, which an octopus doesn't.
Well, we don't know that. We don't know actually. The octopus is a different worker. It's a different type of being. It solves problems that dolphins could never solve. For instance, if a dolphin was so smart, why would it let us strap bombs to it to become a bomb-carrying dolphin? I mean,
they've never done that.
Well, the
U.S. Navy has never done that.
No, they've never blown up. But they did experiment with training dolphins to deliver ordnance.
The dolphins proved too unreliable.
Yes, that's correct.
All right. Well, we're way off topic here, so...
yeah, I know. Yeah, I'm sorry. But thanks for the question. That was really good.
Yeah. But have a nice evening.
All right. Thanks for the call.
Thanks for the question. It was great.
All right. And so that line is open. If anyone else wants to give a call in, that's in live only during the show, 603-967-4030. And so we do have a bunch of questions that came in, and I do want to thank Amanda once again for her good work here. And
she's wonderful that way. I mean, she will. I mean, you should hire that girl. She'll give you every question. She'll keep your show going, man.
Yeah.
If you're having a short night, man, she'd figure it out. She's good.
Good to know. Leslie on YouTube wants to know if you can comment on the sensationalized coverage of the near-Earth asteroid passes.
Oh, that's a really good question, because on our planet we have a number of near-Earth asteroids, and here's the thing: little by little, we're actually removing a great many of these from the list, because there were some that were considered dangerous. There were some that were, considered very, very potential threats to us. Well, the fact of the matter is, these objects, once their orbits were recalculated, many of these objects were found to be less of a threat to us, and they were thus removed from the short list. But that doesn't leave out rogues and things that can show up unexpectedly, like Oumuamua.
Right.
Oumuamua was 700 feet long, 70 feet wide, roughly, and it came whipping through here at 86,000 miles. Well, it left at 86,000 miles an hour, and came through here at over 150,000 miles an hour. But the bottom line is, this is something that we had no knowledge of ahead of time. So, and I got to say, the NEAR project actually is very near and dear to me. I don't mean that in a funny term, but there was a scientist on that project by the name of Mary Ellen Murphy. And Mary Ellen Murphy was a chemist, and she was assigned to study some of these near-Earth asteroids. And when the project came to an end, she, of course, had a very fruitful role in that project, landing on, of course, Eros. And then along comes the OSIRIS-REx program. This was another program. She wasn't part of that program, but she had passed away a couple years ago. And when OSIRIS-REx was doing a call for remembrances of past scientists and people of importance, I included Mary Ellen Murphy in that list, and I sent that to them, and so now there's actually a little microchip with Mary Ellen Murphy with an image of her smiling, circling the sun, and it'll be there for billions of years. Yeah, it's sort of a little aside. I don't mean to.
That's pretty nice.
Yeah.
Again, before we get too far away from the Oumuamua, what do you think about Harvard's paper on that? The possibility of that, it could have been an alien probe.
Yeah, I think that was truly an open-minded statement to make.
Right.
Because the fact is, in all likelihood, it was just a rogue that got loose from its original solar system, ejected from its solar system. But it was actually a very spindly object, something that we don't have anything like in our solar system.
It doesn't make sense that something could be created like that. Usually things are globular or more globular than others. Than other shapes.
Right.
Just by gravity, the force of gravity.
That's right. And beyond a certain shape, beyond a certain size, rather mass, especially, objects tend to be spherical. So in Oumuamua's case, it wasn't that way. So there was a thought that said, well, look, because we don't get spherical, it's not a spherical object. Could it have been an alien probe, just defunct after many millennia, actually millions of years of disuse? And the answer we won't know because, of course, Oumuamua is Oumuamua gone. It's Oumuamua gone. It's actually just disappeared. Heading out toward the constellation Pegasus right now. But it could it have been? Maybe. I mean, I can't say no. It'd be arrogant to say, yeah, it couldn't be a probe. I mean, science has tended to have a closed mind at times, but I'm tending to just stay open to the possibilities, but not be married to any one of them. I think that it merits investigation.
Right. We do have a caller on the line. Caller, your first name and where are you calling from?
Hello, Martin and Mark. This is Ronald from Minnesota.
Hey, Ronald. Welcome to the show.
I had a question. Thank you. And thank you, Mark, for being a guest. Really a great treat to have you on and with Martin and have you on for the whole hour. My question is something about visually seeing something that you never see. For instance, I don't believe that UFOs are not there. I believe UFOs are real, but I have not seen one yet. So how do I convince myself that UFOs are real or aliens or anything that we are talking about on the paranormal channel, KGRA radio and other YouTube stuff? How do we evaluate something that is real that we have never seen in reality? That might be a good way to put it. Maybe rephrase that. I don't know.
Ronald, that's an excellent question. And I do have an opinion. It's not necessarily the right opinion, but it is a thought. My thought is that when we look at how many planets have been found, and there's some people that will say, oh, you can't talk about all the planets that's found and say statistically, blah, 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 blah. But actually you can. If you look at the fact that there's a lot of things going in the direction toward life, all right? Yeah. Yes, the universe is out to kill us. It is. There's a lot of reasons why we'll die very quickly off the Earth. But given what we have here on the Earth with the ultraviolet shield provided by our atmosphere, with the magnetic field which provides the ability to maintain an atmosphere, we're not the only planet that has that. And I guarantee you that means that based on the fact that life started here by itself, we did not create it. We didn't have a role in that. Okay, it happened, and the Miller-Urey experiment in the early 50s showed that the building blocks of life, amino acids, were created just by bombarding what we thought was a primordial atmosphere in a flask with lightning and having water, having a water cycle in there. And we saw the building blocks of life form. And after a week, they saw a whole number of amino acids. And then 50 years later, they reviewed those vials. And those vials from that experiment, there were 22 more amino acids that were undetected at the time. So what I'm getting at is the planet makes the building blocks of life all by itself. Comets deliver the building blocks of life, without any influence from us. Asteroids deliver a lot of water and building blocks of life. And meteors do the same. The Murchison meteorite, when that landed here, that actually was loaded with amino acids. So, if you look at it from that perspective, this isn't unique to our solar system. This is probably, and I can't say for sure, but this is probably something that's been repeated elsewhere for a lot of different systems. Therefore, the opportunity that life could arise, carbon-based life even, life that's carbon-based. Let's not even go to silicon-based life and everything. Let's just say carbon. Carbon-based life could very well have arisen, elsewhere. I believe it. I think there might be life under Europa's ice mantle. That icy mantle of Europa, it has a 90-mile or 60 to 90-mile deep ocean underneath that ice. It's possible that ice that is hiding life underneath, microbial, no doubt. Same thing with little Enceladus. It's only 300 miles across, and it's Saturn's moon. Okay, and Europa is Jupiter's. Enceladus is only 300 miles across, and it has these what we think are hot smoking vents like we see in the floor of the Pacific and Atlantic Oceans. These black chimneys that are spewing mineral-laden water that bacteria love. Okay, so that begets another form of life that feeds on the bacteria, and then those feeders get fed upon themselves, et cetera, et cetera. Is it possible? Yeah, it happened here. It happened here, and the life here at the ocean vents is chemosynthetic, not photosynthetic. Photosynthetic like plants. This is chemosynthetic-based life. It's an entire oasis on the bottom of the oceans where this is happening, where there's never any light. So, could that happen in Europa? Yes. Could it happen on Enceladus? Sure. Why not? We don't know.
Yeah.
So that said, I think that there is a possibility that life, and this is my favorite line from Jurassic Park, Jeff Goldblum. Okay, he says, life will find a way. Life finds a way. And I think that that's very true. I say that often, okay, because I really do. He played Ian Malcolm in that movie.
Yeah, he was great. Yeah,
it was really good. I kind of like that. He was the cautionary scientist there, and he would say, and he said, life finds a way, and nobody else believes him when in fact life does find a way. So yes, that's fiction, but the fact is, what he's saying is something that's not based on fantasy. It's actually based on factual base. Okay, like for instance, when 96% of the species and so forth on this planet were destroyed in the Permian era, why should anything have come back? That little 4% was enough to actually put diversity out there of such magnitude that we have what we have now. Hundreds of millions of species alive now.
Yeah.
See, so,
yeah.
And here's another thing too, Ronald. When you look at every life form on this planet, every single one of these that are beyond just single cells, every single one of these higher life forms is bilaterally symmetric. What's that mean? It means that they're the same on the left side and the right side. Wait a minute. That's symmetry. Where's that come from? And why don't we have, like I've said before, pogo stick cows bouncing around in the pastures? Why don't we have one-legged creatures? Okay?
Good point.
We don't have that, right? So this is a template, see? This is a template the universe provides for life based on that ubiquitous element known.
Well, I can tell you something,
it's everywhere.
Mark.
We find it everywhere.
Mark,
there's carbon.
I just want to say thank you, and I always learn when you're talking. I don't know if I understand everything, but I learn. That's the key part.
We only have about 3 minutes left, but I would like to address...
All right, thank you.
Yeah, wait a minute. I'd like to address part of your question that really didn't get answered. You say, why should I take UFOs seriously? And I think that was also a good question, and it's kind of along the same line. There's so much of science, so much of astronomy that is observational. Well, almost all of astronomy is observational, but
we can't.
I don't know if you want to address that, Mark, but I mean, it's just that there's so many people that have seen something, and there's trace evidence too. I think I was
actually
go ahead,
Martin.
Yeah.
I'm sorry, but I know you only have a couple minutes left, so I wanted to just say. I was addressing it, but I didn't actually finish the point, and I thank you for putting me on track, up to you and Ronald. The bottom line is that with all these templates like I'm talking about for life here on this planet, you have to look at it as this has happened elsewhere. Therefore, when you look at the number of exoplanets that have been found, all right, just in that little tiny fist-sized area of space over your head on a summer night, okay, in the constellation Cygnus, how many of those fist-sized areas are all around the universe that we see? Many, many millions of those overall. And we have a lot of planets. In fact, we think there's more planets than there are stars in the universe. And now that means that you have a possibility that with the templates that we see that have been exploited here on Earth for life, that most likely those templates have also been exploited elsewhere, because the universe is the same wherever we go. There's little differences here and there, but the chemistry, the periodic table of the elements, this is something that was all generated by the stars and by other processes in the universe way from the very beginning and ongoing to this day. So life, in my view, is probably the rule, not the exception in this particular universe.
Oh, thank you.
Hey, Ronald, thanks for the call.
Yeah, thank you very much, and have a great night.
All right,
bye-bye.
Thanks, Ronald.
All right, so we're getting right near the end, Marc. So, just if you would remind the live listener at this point, or the person watching on YouTube, where they can check out your show in about a half hour from now.
Well, on Sunday nights, I have the KGRA radio show. It's called Sky Tour Radio, Sky Tour, one word. And on clear nights like tonight, it's a beautifully clear night, we have a little, it's basically our live stream that we do. It's called the Sky Tour live stream. And we take a tour of the deep sky objects in space, and we show them, we talk about them. And some of the information like I'm talking about here tonight, we kind of go through it that way in Sky Tour live stream, and we take questions from the chat, and sometimes have guests come on with us as well. So we're going to spend some time tonight after this broadcast doing that. So join us, Sky Tour live stream. Subscribe, hit the bell, get notified when we go live again. And we are subject to the weather, but we're trying out our new full remote operation tonight. And there's a few little quirks that I've noticed already, but I'll get past them. Right. But, come along and either watch the dismal failure or the tremendous success.
Excellent, Marc. So we're totally out of time. Thanks so much. And
Thank you.
We'll talk to you soon, Marc. You take care and have fun tonight.
Thank you. Bye-bye.
All right. Bye-bye. All right, everyone. So that's it for our show. Thanks so much. I want to thank people that help out with the show. We have Evan that helps out during the show. We have Keith, and we have over at the Dark Matter Digital Network, we have Eric, who is now helping us out at KGRA Radio. Thanks to you, and thanks mostly to you, the listener. Without you, I wouldn't be anything at all, wouldn't even be here. So thanks. And remember, next week we have Professor Greg Elligan. I don't know exactly how. He's got an unusual last name, and I will get that pronunciation down. Thanks so much. And remember to keep your eyes to the sky.